Welcome back to everybody. I hope you had a chance to stretch your legs and get a drink. My name is Sarah Cullen. I'm the Programme Manager for Pitch-In, and I'm going to introduce the second set of our showcases. And the highlights from our themes starts with batteries and big data from Professor David Howey at the University of Oxford. If you'd like to start your talk, please, David.
That does require me to unmute. Excellent. Actually, if I do this, can you see Zoom on top, or can you just see my slides?
We can just see your slides presented, so that's fine. Thank you.
That's great. I'm juggling multiple screens. So
yeah, no, it's fine.
We're all professionals at this now. Anyway, okay, great. Well, it's a pleasure to be here, and thanks for inviting me back. I enjoyed doing a similar talk for a smaller group on energy about a month ago, so it's great to hear about some of the wider things going on in the projects. So yeah, as you mentioned, I'm Dave Howey from University of Oxford, and our focus is on batteries in my group. We are a bunch of engineers as opposed to materials and chemistry people. So we take batteries and we figure out how to model them and how to control them, that kind of thing. And today I'm going to be talking about a project funded through Pitch-In, which focuses on batteries and data. And it says batteries and big data, but we could say big and messy data. And the key result that I want to talk about is a database system that we've been working on for unifying how we handle lab test data from our lab. So to give you a bit more context, these photos actually show one of my PhD students. This is Trishna, and one of our battery testers in the top right. And Trishna probably has generated tens of gigabytes of data in the course of her PhD. So that's the kind of thing that we're dealing with here. All right. Okay, so what's the challenge? Well, battery testing, management of data is a complete pain. The issue is that at the moment, there are tons of different systems on the market, and they all have their own software. They all have proprietary quirks. There's lots of manual intervention involved in getting these things to work properly. And some of them work better than others, but yes, there's no interoperability. So a typical workflow when you're testing a battery, say for lifetime or performance, is completely crazy. So let's say you want to analyze some data, you would dive into the battery's PC, the battery tester's PC, find the data you want, search for it, then export it, transfer it to a different PC, search within it in MATLAB or something like that, or Python, do your analysis, come up with a plot, then think, oh, it's not quite the data set I was thinking of, and go back and start the whole thing again. And so it's a complete time waste. And you know, we really have to do better. And there are some proprietary software solutions available to help with this. There's a company called Voltaic in the US who produce a very nice piece of software, but it's relatively costly and it's not really oriented towards academia. And that may change in the future, which would be great, but we just decided that we needed something that we could open source and build a community around. It's worth also saying that a lot of the software and data management practices in this space are, I'd say, lagging behind other fields, notably pharmaceuticals. And this means that you've got a lot of incremental gains and lost productivity. All right. So the aim of the project was to develop some kind of unified approach to this issue. And the tool that we've been working on is called Galvanalyzer, which I've realized with hindsight is a bit of a mouthful. We may change that name later on. Certainly when I have meetings with colleagues in other countries, sometimes people really struggle to say it. But anyway, so Galvanalyzer is basically the idea is quite simple. You've got a database in the center of it, and you have these apps, small pieces of software called harvesters, which are bespoke for each type of battery tester. So we try to understand the file format for each type of battery tester, and we write a harvester program, which every minute or 10 minutes or whatever goes into the folder where the data is stored and says, is there anything new? And if there is, then it passes that data and puts it into the database. And so the beauty of this is that everything in the database is then in a unified format, irrespective of what battery tester has been used. And then we've got a web app and some browser-based features for looking through the data and setting up metadata and stuff like that. At the heart of this, I won't explain this, but there's quite an interesting schema, which is fairly flexible. This was developed by one of our software developers called Luke Pitt, and it allows a nice balance between flexibility, but also requiring you to do certain things. One thing I will say is that metadata is really important in this whole process. We've realized that the battery testers themselves don't enforce any metadata, so they don't ask you to say, what battery are you plugging in, who's doing the test, none of that. So we've had to impose that over the top on the database system. And at a bare minimum, we need to know some kind of unique ID for the battery. We need to know some kind of ID for the owner, what's the purpose of the experiment, and which piece of equipment is being used. And at least with that, you can then do searches across lots of different pieces of equipment. So the results, the tool that we've got at the moment, we have a fairly advanced stage of development. We're hoping to open source it quite soon. I'd say it's about 80% there. At the moment, we're working on documentation and stuff like that. But the tool basically has this bespoke harvester that I mentioned. And if you go into the web interface, you'll see a kind of a list of different data sets from different testers. Here's an example. And then you can fairly quickly pick one data set, have a look at some of the data. This is using a very nice toolbox called Redash, by the way, if you're interested. So a web application framework. And you can do things zooming in and out, picking subsets of data and so on. So Redash is something that basically allows us to do this quite quickly. We've actually had to build on top some other stuff to deal with metadata, because Redash, unfortunately, well, it's not unfortunate, but it's a read-only system. So if you want to actually write to the database, you have to do things slightly differently. So in terms of lessons learned, I'd say that we've learned a number of lessons, but I want to just highlight 3 in particular. So the first lesson is that we have, over the project, we've had to adapt our requirements. When we started a couple of years ago, more than a couple of years ago, I think, I don't know, time has kind of become warped in my mind. We thought that we would create a tool where you do everything through the web browser and it produces publication quality plots. And it became quite obvious that that wasn't really required. Most people doing research would generate their own plots in MATLAB or Python. And what we actually needed was a tool which handled the front end stuff, got things into the database in a nice way, and then had a really nice API. So this is just some example code from an API, so that people could pull data into their own analysis code and use it. So we've had to adapt requirements as we've gone along, and we've slimmed down our web-based GUI. Secondly, and I think this was a point raised by others earlier in the day, it became quite obvious that we really needed some professional help. And we're very lucky here at Oxford to have a group called Research Software Engineering, who can help with things like getting projects onto professional footing, making sure that version control is working properly, making sure that unit checks and stuff are happening properly. So I'm absolutely grateful to Luke Pitt and Martin Robinson, our 2 developers who worked on this project, have done a really fantastic job. And I think it's really changed our attitude to how to do these kinds of projects from now on. And if you're doing a software project, do yourself a favor and get some people who know what they're doing involved, because it makes a huge difference. The third lesson is that working with others is key. And we've been fortunate to be part of a network with lots of US national labs, university in Germany and elsewhere. And we've realized that actually this problem is not a unique challenge just to us. Most labs in our situation have a similar challenge, and many are developing their own solutions. And we've started talking to each other, which is great, because there's no point reinventing the wheel. So this is an example from a very nice website called Battery Archive, which shows a solution developed by Sandia National Labs in the US. And the point here is that in the end, this has to be a community effort. We can't just maintain our own version. We need it to kind of get out of our lab and help others as well. So we've currently got a number of these projects going on around the world, and we are sort of developing in parallel, but we have meetings every fortnight. We talk to each other. We're in the process of developing a REST API so that the different databases can talk to each other. And in the future, we might unify some of the projects. Finally, of course, these are just tools to do cool things. And so in terms of next steps for us, I'd say that we are working on outreach. I'm involved in a paper with, again, lots of US national labs and universities where we are trying to ensure that these issues are raised very widely. This paper is still under review, but once it's out, I'd be happy to send it to you. So we're making sure that we're trying to build some kind of community effort around this. I mentioned open source briefly as well. We decided at the get-go of this project to make sure that it was going to be open source. We haven't actually open sourced it yet, but we do plan to do that quite soon. We've had a number of inquiries from people, so we're hoping to do that over the coming months. And of course, in the end, we want to do cool science as well. So ultimately, we just want to make sure that people, certainly inside my lab and then wider, are actually using these kinds of tools and using them day to day, and it actually benefits their workflow. So this is an example from a recent paper where we've done some analysis of how batteries degrade under certain scenarios. Okay, I think that's about it. Hopefully I haven't gone over time. Didn't want to make it too long, but I just want to say a huge thank you, especially to Andy Gilchrist here in Oxford, who's really facilitated this whole project from our side, but also to the software developers that I mentioned. And just to say, we are very excited by this whole space, batteries and data, not just lab data, but also field data. We have other projects going on where we're applying machine learning techniques to predict battery failure from field data. And just to give you an idea of the scale of that, we are dealing with about 500 million rows of battery data in one project at the moment. So it's about 50 gigabytes to predict battery failure in sub-Saharan Africa and off-grid systems. So really exciting, lots going on. Happy to chat further with anyone who's interested. Thanks.
Great, thank you very much, David. That was a great presentation. We're now moving on to managing the use of IP in IoT by Dr. Frank Tietze at Cambridge University. If you'd like to share your screen, please.
Okay, hello everyone, and following up from David's kind of final comments, I'd also like to say upfront a massive thanks to the Pitch-In project and all the team that has been involved in this project and supported us throughout the journey. So this is also about, of course, digital, but slightly different topic. So what we've set out to do here is to automate licensing payments for intellectual property that sits within connected and distributed electronic devices. And so in my research group at the engineering department, we actually have a major interest in intellectual property. While most of our projects are more of innovation management, IP strategy type of projects, this is one project of our portfolio that looks into the future of IP management and how technologies will change the way how IP is managed, and particularly now how in this project we looked into how distributed ledger or blockchain technologies can impact the licensing business process, which is mostly manual and prone to lots of errors. And as one of the lessons learned from this project, I became increasingly convinced that this is one of the business processes that will get automated in the futures with distributed technologies such as blockchain. And let me go a little bit further into what we've actually done. So here is just a little quote from another university across the ocean. And this is just one tiny little example of royalty audits that need to be done and that they are costly. And if you think about the big four, the audit companies, EY, Deloitte, PwC and KPMG, they are basically huge intermediaries, and they do lots of things. Amongst them, they do also audits, not just for annual accounts, but also for licensing payments, and the need for them is kind of at the moment there, because that process is mostly still manual, and there's a trust problem between licensor and licensees. And that's why these companies have a business value proposition to help with that. And what we've basically looked into here is, how would a digital economy work without those players? Can that be made happening? And in a way, just a bit of a context here, we are not the only group that is thinking about how IP can be kind of put on the blockchain, if you want. So even though we are more interested in not the assets, but the smart contracts and the transactions, but there's a lot of dynamics in industry. Nokia has recently introduced and announced a marketplace for data, where you can trade data and transact data on the blockchain. IBM has made a recent announcement, as you see here from April, that they are going to put their patents on the blockchain to create patent markets, and this is more about selling and trading patents. So there are a number of use cases, and that's what we have been at the beginning trying to do. We had an idea of that distributed ledgers could be used for licensing payments and automating licensing payments that sit within IoT devices. But we learned so much more throughout this Pitching project. In that sense, this project has been really, really valuable for us. This was a bit of a journey, and just showing this here, with the project actually goes back to kind of like, well, almost 4 years ago now. The upper bit of this is interesting. So we've, after we got the Pitching grant, lots of things happened, and the idea was to develop a prototype, and I'll say a little bit more about this later, to demonstrate that this really works. But throughout the Pitching project, we managed to engage with a UK-based tech embedded software company, and that has been really, really helpful. Also, as one mechanism that I think was really great within the Pitching project is that we could use internships. So we had a visiting students who did a master thesis with us, who worked with that company. And maybe it was also a bit of a coincidence and luck, but him coming from the Technical University of Munich introduced us to colleagues there. And that really built a relationship. And we've done a number of projects now with them throughout the Pitching duration. We've in fact funded a little company, and we'll see where that goes. And and towards the end, or well after the Pitching grant, we but still funded from the Pitching grant, we were able to participate in the tech entrepreneurship program here at the University of Cambridge with this idea, which also won us the Cambridge Blockchain Prize in 2020, or one of the 3 prizes. Yeah, maybe just a little bit more on the partnerships. As I said already, we've really managed to develop a partnership with the Technical University of Munich. It all started with this one student, and you could say, well, it was luck because he was very engaged and he really liked the idea. But we've worked with colleagues at the TU Munich throughout since then on what is called the Lead User Project, where we will in fact host an industry workshop in 2 weeks' time, where we bring together industrial players and with the idea to build a consortium. We had the idea to do this already last year when we were on the Pitching grant, but because of COVID, I think that all got a bit delayed and more difficult than we had anticipated. But also we got basically in touch with colleagues from the TU Munich, from the computer department and software development department, and they helped us again through some students to work on our prototypes. So that helped create resources here in our group. Besides that, we also managed to build a relationship closer here in Cambridge to the computer laboratory, as we managed to hire a postdoc who worked there before and who was very closely linked to colleagues there, and that has been helpful to kind of build partnerships internally within the university. And then I've mentioned already the work we've done with N Technology and Research, which we've also with them worked on an Innovate UK grant, which unfortunately didn't make it, but that has been such a great experience working actually with an industrial player. And in fact, this is a bit how it turned out to be the team, and the student from TU Munich is now kind of part of the core team. And we have a number of advisors that we managed to connect to throughout the Pitchin project. Maybe a little bit more actually, that you understand a bit better what we are actually doing. I've already said there's basically inaccuracy and inefficiency in the licensing process. And this is not about negotiating licensing agreements. Our project starts where a licensing agreement has been put in place between the licensor and the licensee. So you could say would be University of Cambridge, the Tech Transfer Office, Cambridge Enterprise, and one of the companies they give licenses to. We're particularly interested in licensing relationships where it's about digital technologies that find their way into IoT devices. And that process is, if you want, so the payments for these licensing fees is very much old school, if I can use that word. It's very manual. Licensing manager sits there, gets prompted maybe by a little bit of an administrative software tool to say, okay, in 2 weeks' time, you get to make a payment, better prepare now. And then that person pulls out some data out of the ERP system and uses the licensing condition sets out in the contract and then makes some payments. But the licensors, they receive these payments. They have very little means of actually verifying that the payments are correct. And that's why there's the need of audits. Audits are expensive. They don't really add value to the economy. And yeah, that's not a really ideal solution. So this is a bit summarized here. In fact, this is a bit our solution of what we suggest to do. Instead of using data that comes out of the ERP system, we digitize the contracts and put them into our system, and then we go to the horse's mouth, so to say. So we get data from the devices directly. They register in our system, and then we match the ID of the device with an inventory register of the IP that sits within the device, and we call this the bill of IP. And then we match that to the payment conditions that we've extracted from the licensing contracts. Those get digitized. And if you think about licensing contracts, there can be hundreds of pages. But in fact, the conditions that set out the payments are often kind of a core part. But yeah, there are some challenges around the digitizing of these licensing contracts, and we have developed a verification process that kind of works so that the licensee and licensor can agree on the digitized version of those contracts. And then we use smart contracts on the smart contract feature, which is basically built into the blockchain architecture to automate these payments, which has a lot of advantages. Not just eliminates the trust problem, but it also means that licensing payments can be made more frequently. And often licensors basically give credit to the licensees and only get payments once 3 months or every maybe once a year or so they can make these payments more frequently. And something which we then kind of uncovered throughout the project is that this approach is interesting from making licensing payments more accurate and more efficient. But in fact, there's the other opportunity to actually create new licensing models that everybody is talking about, but lots of people have actually difficulties of enabling them. And these are, for instance, so-called pay-per-use models, which then also comes with advantages. You can shift the licensing payments out of the manufacturing stage partly into the consumer stage, and then the total aggregated licensing payments over the life cycle could be, let's say, beneficial to the licensor in the sense that they are higher. And we wrote some papers about the different types of licensing models or combined licensing models, of how they are advantages or disadvantages frequently used features or IP protected devices and infrequently used features. So this is a bit of a vision. We use a distributed ledger architecture, not necessarily blockchain, because that comes with some scale limitations. This is maybe one of the bottlenecks, but we think we can get a way around this, and we also expect that if the transactions grow, that the technology will improve. But at the moment, this might be a bit of a bottleneck. If this is something we can really push forward in a little startup or so, then it will be more of a permissioned distributed ledger architecture. And I've mentioned that inventory register of the IP. We call this the bill of IP, modeled on the bill of material, concepts well known from operations management. And this is the database architecture that we have developed. I won't go into details here. I think I'm running a bit out of time, so I just close with the lessons learned. Pitchin has really been helpful to, first of all, establish that what we are doing has viable application in the industry. We've spoke to various different industry players, and there are various colleagues out there who are exploring use cases. And this seems to be one where blockchain could really work and make a difference. As this is one of the business processes that is likely to get automated, as it's not value adding much in the current stage. We've managed to build a number of partnerships that are likely to continue and live on beyond this project. And we could build a bit of a center of excellence in a small scale, at least at the IFM, build some resources. And we're hoping now, with a bit of a delay, we can establish an industry consortium around this. So it's been really, really helpful. And I'd like to thank everybody again for supporting us with the Pitchin funding, but also with the various other resources. And as I said, this internship really has opened up lots of opportunities for us. It's a small thing, but it really has made a difference. Thank you much, everyone.
Great, thank you very much, Frank. We'll have to move quickly on. The next person to speak is Professor John Clark, who's going to be talking about skills development in the IoT ecosystem.
Okay, can you hear me? Okay, so I'm going to be talking about skills development in the IoT ecosystem. So this is on behalf of the consortium. Well, we became apparent that skills in IoT were of emerging importance. So several of us attended a workshop by the Royal Academy of Engineering, hosted by the Royal Society actually, on skills development to back up Made Smarter. Essentially, skills became one of the planks of Made Smarter, which is a big initiative behind digitizing manufacturing, which is underpinned very largely by IoT. There's an opportunity to develop skills at many levels, and our experience, we're educators, of course, we give courses all the time, but our experience is not just getting the information across and getting the understanding across, that's important. Courses themselves, education themselves, is a great way to actually make friends. So we know in some places they employ 6 or 7 people giving week-long courses to industry. It's a way of making contact, and those contacts tend to grow. So there's a good other reason in terms of developing the ecosystems why you would want to do training. It's not just what academics do, it's what academics do for several reasons, and this is one of them here. Now, we aim to be cognizant about what's out there and plug some gaps where we were best placed to do so. So one of the things which, this is a bit of background, Siemens, one of the big sponsors actually and supporters in various ways of Pitchin, have the notion of connected curriculum, which is essentially providing teaching resources to universities and further education institutes to actually teach elements of IoT or digitization more generally, actually, in industry particularly, and in fact in our priority sectors. The universities you see up top are the partners in the connected curriculum scheme. So, Festo are also integrates with quite a lot of the Siemens materials. In fact, we have Festo kit in our Mindsphere Lounge, which is what we use to engage with the public and also actually do bits of teaching. Apprenticeships are another way. The High Value Manufacturing Catapult actually has various apprenticeships, and IoT are part of some of those. So Industry 4.0 is actually seeping into various curricula, and in fact has been there for some time in case of some of the apprenticeships. Just another thing we take notice of before we decided what we wanted to do. Now, one of the things that we did, and I think this is a really nice idea, incidentally, is Cambridge actually provided executive education. So this is not predominantly non-technical education. As I said earlier in my summary talk, it's not just about the tech. At some point, how do you get IoT projects to be pushed down the technology readiness level or actually adopted in some way? Well, eventually someone has to say yes, and at some point, that's a very high-level person who says, definitely, yes, go for it. So this is getting to yes. If you want to exert influence, then exert influence right at the top. Most management manuals will actually tell you this, whatever you read, influence the people at the top. Now then, there's an interesting, so if a firm wants to go on a journey to digital solution for a variety of reasons, well, that journey is hard and complex. We need to understand how can universities support that process. Is teaching actually a useful means to actually do that? What curricula should you teach? And that could be very varied. And who in this organization should we teach it through? And Cambridge have landed on executive training. This is a really nice idea. It just makes sense on so many levels. So there's a significant opportunity to ease the path to digital solutions by providing executive level education. And this will be to inform in areas of manufacturing, health, and smart cities. Those are the focus of the online course, incidentally. Teach bits of IoT, platform, business ecosystem strategy, but light aspects of technical aspects of IoT. And they've actually followed this up with detailed evaluation with the students to see that it's actually hitting the spot. Now, some of the outcomes, there's no one curriculum, and actually this is an observation Sheffield have made elsewhere. There's no one set of skills you need to do well at IoT. It's actually quite a sprawling set of roles actually within the domain. So learning needs to change through transformation. You need to actually engage broadly. There's a bit of a tendency in many companies, if you mention IoT, to palm it off as, quote, an IT problem. Wrong. It's you need a variety of people to bring their understanding and skills to bear on various problems. So it's not just about the IT. And in this particular case, it's to do with management at various levels. And that could even include financial management, because someone's going to have to make a decision based on cost-benefit analysis as to whether to proceed and things like this. Some things such as use cases and value propositions and some elements of strategy actually may not be clear. And it's useful to work with people so that they can actually work through getting those sort of things right and actually believable. Major outcome, and this is, I've underlined it here, teaching strategic and basic technology aspects of IoT platforms and business ecosystems leads to behavioral change. And that matters because these people attending these courses matter, because what they eventually say goes. Okay, so people started to see optimization opportunities. There's nothing better than for management to see an opportunity itself and then act as a pull for available expertise rather than foisting your expertise on management. This course has prompted people to think. It's a bit like, if you walk through after having gone through a course, everything you see then becomes an opportunity in that sort of domain. Well, we're seeing aspects in that. They've also gained recommendations for future attendances. That's the best form of as a word of mouth, etc. Needs may differ, but there's actually quite a lot of between organizations, but there's actually quite a lot of common ground. So this is the course here, the Internet of Things, an introduction to IoT strategy and technology. If you're interested in looking at any of this, there's a link here. These slides will be made available after today's conference is finished. They'll go online. Please contact Florian and Imogen with the contact details here. Sheffield, we also got involved in the teaching, if you like, in terms of skills development. So Dr. David White has a very varied background and also a class software engineer, incidentally, has developed a 2-day practical course. So this is an introduction to IoT, how to harness machine learning in the context of IoT, sensing, harnessing the cloud, right through to fundamental analytics via ML. So, for example, anomaly detection. It's soon going to be trialed. We haven't trialed it yet, but we are looking to trial it very shortly on undergrads to begin with, and possibly on 16 to 18-year-olds. So we're going to see actually just how far down the chain, if you like, to the earlier parts of the chain, we can actually teach ML and IoT. There are some places, university technology centers, which actually have for 14 to 18-year-olds who have some background in IoT and robotics and things like this. So in this case, IoT, we will try to to try it on some of their students. The thing you see on the right is the Haynes Machine Works jet engine. If you're really taken with this, it's a plastic model of a jet engine by Haynes, who do an awful lot of things, as you may be aware. This is a jet engine model suitable for, I think, for this one is for 12+ years, but some are 8+ year olds. This is cheap, which is part of the whole fun of this sort of thing. We aim to do it cheaply initially, incidentally, slightly too cheaply, because the sensors we got just weren't up to the job. And I should also point out, as a practical level, this has realistic sound effects, which might sound great if you're a kid and want an engine model, but if you've got 10 of these in the lab, it begins to create quite a racket, and we wouldn't recommend it. But that's it. Robotics and autonomous systems, some more work at Sheffield. We sponsored some work in the RAS network, or the Robotics and Autonomous Systems, around Fourth Industrial Revolution, or 4IR, or Industry 4.0 type stuff, as well as various analysis of what skills would be available or needed in the workplace. So this was presented at a Unimaker conference and also at a National Skills and Education conference in actually this quarter. Collaboration by the people you actually see there. They stage an online sort of a hackathon, if you like. It's called an intervention here. That's taken from the report, but it's actually sort of a hackathon to develop IoT problems to solutions to given IoT problems. The notion of starting with a problem actually is very important, particularly if you're trying to engage with non-technical people. And that was actually part of the remit that these people actually had. It was great. 50% of those who lasted the course to the end were female. That's a great result for diversity. And if you want to actually look more at this, you can look at the environmental maker videos, which are available at this link here. So really important stuff. So there's going to be some policy papers which actually emerge from that as well. So we're interested in influencing policy too. So we have a survey on skills, which is open. So anybody who either wants a job in IT, has a job in IT, wants to know what skills are actually required. We're conducting 2 job surveys. Skills assessments. One is for people looking for jobs or considering IoT, possibly by shifting career, but possibly also working in it, and another one from employers, which basically says, what sort of things do you need? And we're going to try to marry these 2 together. So if you can, please do sign up for these. They should be completed within 10 minutes, each of them. Don't need to complete both either. One which you find particularly of interest to you, please actually have a go at our surveys. The results are going to be published online when we get them. We're expecting these by the end of June. And finally, we said we'd fit in with what's going on. Well, the Catapult, the Digital Catapult, have an IoT discovery program, which actually takes people on a journey, really. The mechanism, so you can actually see what's here. You actually go from beginning, from problem analysis, right through to implementation over or certainly in essence, as a prototype, over a period of about 12 weeks. So this is basically, you get engaged with digital experts with a variety of skills needed. They look at the business side, they look at the techie side, etc., and they will walk a company through what it wants to achieve. It's not actually for individuals. The company subscribe to this, and they can send a whole variety of people on it at different times for different aspects of it, which is great because it's not all about the tech, and the tech itself is actually quite broad anyway. So we're actually sort of working with them. We may participate in another delivery of this, and we're going to be talking to them about low-cost IoT anyway, which is, you see, is one of our pitching themes. Interns, this is my final slide, so we'll be back on time very shortly. These are typically 2 to 3 month employments, often over summer, but not necessarily so. All the universities had positive experience of employing interns on short-term tasks. So sometimes they led to people taking up PhDs in the area. So for a few £1,000, you've actually got a really motivated, and they know what they're letting themselves in for. It's a nice little taster. They let themselves in for something much bigger over 3 or 4 years to do a PhD in IoT. At least one Innovation Accelerator Fund bid has now been gained by one of the interns. I think it might now be 2, actually, given to what I've heard today. An MSc student, as you've just heard, helped build international relations with TU Munich. Contributions, focused work can generate really helpful resources. You heard that in the last talk. All the actual sites actually believe that. And of course, these are focused and driven events here, undertakings. Contributes to building relationships with local stakeholders. Certainly for one of the projects, local stakeholders were very keen to get involved to give mentoring, technical advice, in order which the students then produce resources which are then released to the ecosystem. And companies are very keen to get involved with the interns. And actually, the really pleasing experience of the whole pitching project is that companies are and external agents, external bodies, government, for example, local council, are very keen to work with academics to solve a whole variety of problems. And that's a real positive, motivating experience for everyone on the project working in IoT. There's a real opportunity to build the non-technical skills, and maybe this is the big lesson and the big thing which came out of certainly one of the projects here, a project of 10 students working as teams and helping each other under pandemic conditions, incidentally, it was with mentoring provided by SMEs, and SMEs were very keen to get involved, even though it's just a student intern, very keen to get involved. And I'd just like to point out that there are several examples. Interns can be simply stunning and can achieve a hell of a lot in 3 months. And that's, I believe, is 12 o'clock, and we're back on time.
Thank you very much, John. Moving on to the next presentation is Engaging with the Regional IoT Ecosystem During the Pandemic by Professor Savas Papagandis. If you'd like to share your screen, thank you.
So hopefully you can see my screen now. So many thanks, Sarah, for the invite to talk to today's conference, and of course many thanks to Pitchin centrally for the funding and support to undertake this project. My talk will actually continue on very nicely from John's last slide, especially on the point of building relationships during the pandemic. So I thought I'll focus on one aspect of the project that I found the most interesting when it came to engagement and trying to create such relationships with local stakeholders under very challenging circumstances. So during the pandemic part of the title is, of course, because it was not planned in any way or shape. The pandemic hit us at the worst possible time as far as this project is concerned, and has effectively made us redefine much of what we originally thought we will be working on and find ways that we can still meet our objectives. So our project had, well, I should have said at the beginning, I'm a professor of innovation enterprise based in Newcastle University Business School. And that will explain why the project had the focus on trying to identify barriers to IoT growth and ways also that we could support stakeholders to address those barriers. So the first stage of our project was effectively trying to create the leads for stage 2 and 3. So we went through a process where we extended the IoT Nations database. We had a list of more than 1,000 companies, up-to-date list of more than 1,000 IoT companies, and we had a lot of metadata about them. We were thought initially to cover the whole UK, but then we decided to focus more on the Northeast, because on stage 2 and stage 3, we wanted to start building those relationships with the local companies. And of course, distance plays a role in that. So stage 2 was looking at the barriers that these companies were facing, maybe technical, maybe legal, maybe financial, maybe, you know, because they couldn't find the right kind of skills, and identify opportunities through which we could help them to overcome them. And stage 3 was going to work closely with them to provide support where possible, or just a direction, if we couldn't provide support through other schemes like the Arrow scheme we had in Newcastle, so that they could actually deliver on those sort of promises. Now, the pandemic hit us at the worst possible time, because just as we've created the database of potential stakeholders to start targeting and organize our very first event through which we were going to start engaging in that dialogue, social distancing measures and lockdowns started happening, and as a result, all our plans were thrown up in the air, and we had to redefine how we're going to engage with those companies. As you can imagine, we brought things online. We organized a monthly webinar on all sorts of areas related to IoT, and we had a great turnout of both speakers and participants. And as sort of a spin-off on that, there was also a morning sort of show that happened through our partners in IoT North that has now been on the air, so to speak, and is gaining traction. So the lessons learned, again, focusing just on the engagement side of things, because without building those relationships, much of what we aim to do will have not been possible. sort of worked and sort of didn't. So on one hand, of course, faced with the option of doing nothing, doing something felt like the better option. So we decided to move things online, and to a great extent, it has worked much better than we originally anticipated back in March 2020. When we're going to have our first event. There may have not been pizza and beer in the event, but nevertheless, the content and the speakers and the questions and the discussions that we had were engaging enough for people to keep on coming. On a positive note, we had speakers from around the world, which we didn't, of course, plan initially because we're targeting the local community. So we were naturally thinking about having local speakers. We also had participants from around the world, which again, we didn't expect. And as time went by, we had more and more of them joining us. And it was also almost free. We had to invest a little bit in the beginning to spice up the tech, get some better microphones, get some better cameras and so on. But fundamentally, the cost was not significant. What was, though, significant in terms of overheads was the time we found ourselves doing a lot of video editing and trying to organize the content in a way and package the content in a way that will make sense beyond the webinar itself. For instance, we prepared reports on each of the events. So we had both the text, but also the video that accompanied that, and they were all posted online. And after a while, the whole novelty of going online and having this kind of events started kicking in. A lot of events series were created in addition to ours. So there was the online event fatigue that we've all suffered, and we're still suffering to some degree. Hopefully, we'll end soon. But fundamentally, although the engagement still, was there, what I felt was not as much as I would have at least liked to be there. The opportunity to create those kind of relationships. Because on this kind of events, there are certain things you can do, but there are also a lot of things that you can do, like, have a chat over a cup of coffee after the event and sort of find more about the individuals who attend the events. So as we're going forward with this, because we have created a very strong relationship with IoT North and the local ecosystem, we started thinking what will be the next steps. And on one hand, we do feel the urge to go back in the business school and organize events in our fantastic event space on the 8th floor of the business school. And enjoy some catering, enjoy the views, enjoy the speakers. On the other hand, I think we'll be taking a more conservative view in this and more gradual view in this. So we'll be keeping the online arm because it has brought a number of benefits, but also start thinking about the nature of the interactions and how the face-to-face will actually facilitate and bring more benefits than the online arm. And then what is it that the online arm cannot bring? So maybe in the first instance, what we're thinking of doing is instead of having a full online series or a full offline series, we'll move, say, 25% of the events going forward to the business school and have the face-to-face side of things. And then see how we go about this and whether the appetite is still as it was before the pandemic, or maybe that the new norm has actually made significantly the way that we engage with each other. And also, how can we continue the discussion? Because one thing we found is that in this kind of events, it wasn't the same sort of people, coming back because the topics will be varied. So how do you create a space, a continuous space through which people can engage and that will be appealing to them and is not just on the immediate and very direct topic that they are interested in based on whatever they're working on. So I think what we've learned is that the question is perhaps a little bit more important than the answer itself, because I'm still not sure what the answer is. We'll find out as we're going along. And the most important takeaway from this is sort of feeling comfortable to not know how things will work out, because things kept on changing on a monthly basis. And we're going to have a sort of plan, a long-term plan. And being able to be agile enough to maintain this kind of engagement was, I think, a critical point in the success of the overall project, and not just the engagement side of things. The only other thing I like to mention is that although we were particularly good at engaging practitioners, it would have been so much better if we could also engage more with our academic partners. To some degree, having the events at the business school was going to achieve that, because we'll have a lot of students and a lot of colleagues. But of course, the moment that didn't happen, we had to, change our plans a little bit in terms of how we'll disseminate and target the stakeholders. So maybe again with the nature of the interaction, the frequency of interaction, the mixture of the engagement will be able to address better the balance of the stakeholders that we can target through these engagement plans. So that's me. If anyone wants to find more about the project and the other sides of the deliverables, there's a website that you can visit. And if anyone has any questions, I'm more happy to take them either via email or through the chat. Thank you.
That's great. Thank you very much, Sabas. And thank you very much to all of our speakers. Some really great and interesting presentations there. So really appreciate those.